Alright, I know we've covered a lot of material in the last week, so I'm going to spend 10-15 minutes talking about some of this to help you in your review. So our focus is on understanding how we can measure initial velocity of an enzyme catalyzed reaction. And it begins with the fact that product concentration increases over time. Sometimes, in some cases, fairly rapid increase in the amount of product generated. And then that increase begins to taper off. So remember, we're looking at product concentration on the Y. This tapers off as effectively we begin to form an enzyme substrate complex that can only go to product and all of the enzymes involved. And this is why we no longer generate more product, because the enzyme is saturated with the substrate. So if we're looking at time, this occurs, then we can measure the rate. This would be the rate at which this generation of product occurs. This rate is equivalent to V0 if we apply the Michaelis Menton assumptions. And the number one assumption is that the ES complex is at steady state, that the change of in the concentration of our ES complex per unit time is equal to 0. Another assumption is that the breakdown of the ES complex is greater than making product. So we measure this breakdown by what's K minus 1. K is a rate constant, and K2 is the rate of formation of product. And so as long as our K1 is much, much greater than our K2, then we can assume an equilibrium between the formation of ES and the breakdown of ES. And we can also determine, this formation would be K1, we can also determine the affinity of our enzyme to our substrate. Okay. If we just simply take the rates of the breakdown divided by the rate of the formation, okay, that gives us an affinity. So when this ratio is fairly high, that means that our breakdown is greater, and therefore the affinity is low, because if I draw it like this with a big arrow, our enzyme substrate complex tends to want to separate after it forms. So we have a low affinity for enzyme substrate. And of course the opposite is if our K minus 1 over K1 is low, that means our denominator is large, and so affinity is high. So, let me go ahead and transition here. Michaelis' Menton equation measures our initial velocity, and it actually is computed by using our maximum velocity and our substrate concentration, a constant called Km, Michaelis constant, plus the substrate concentration. Remembering the Michaelis constant relates all those K values, K1, K minus 1 plus K2 over K1. Okay, Km operationally, means in the experiment, is equal to the concentration of substrate, giving you 50% of the maximum velocity. If we look at our Michaelis-Menton plot that we drew earlier, okay, now we're looking at a number of different initial velocities versus substrate. Km then would be half of the maximum velocity, which would be about here. Okay, and that's the substrate concentration that gives you the half maximum velocity. Important. K2 determines the efficiency, or the how well that enzyme converts substrate to product. K2 is approximately equal to K, what's called the catalytic constant. Okay, and the catalytic constant simply takes the maximum velocity of that catalyzed reaction. Okay, when the substrate is saturating the enzyme at its total concentration divided into that maximum velocity gives us the rate. Determine the absolute efficiency of the second order reaction by taking Kcat and dividing it by Km. Okay, Km Vmax can be determined from plotting data like this, substrate concentration and initial velocity, by taking the what's called the double reciprocal of the Michaelis-Menton plot. When we do that, you get a line. So on the x-axis we're looking at 1 over substrate concentration. On the y-axis we're looking at 1 over V0. The points will be kind of aggregated here. And then by taking a linear regression, we get an equation, we get a line that intersects the y and the x-axis. The double reciprocal plot looks like this. 1 over V0, taking V0, taking the reciprocal. And if we take the reciprocal of this equation, then we're going to end up with Km over Vmax times 1 over S plus 1 over Vmax. Understanding most of the foundation